All right. So can everybody see and hear me? Can you hear me, Scott? Awesome. Let's get started. All right. So to kind of start off here, one of the things that I've kind of decided is you guys are going to be the kind of the group that we do this for. So these first three sessions, the first one, this one, and the next one, we're going to do a lot like what we did on the first one, where I'm going to go through some basic things and show it to you. But in the last part of today, when we go into Zoom, one of the things I want to do is spend a lot of time getting questions and feedback from you all to tell me specifically some of the things that you want to know. Because now I'm going to actually go ahead and spend the next week or so building out a full course, building out courseware. So you're gonna get, digital textbooks, PDFs of textbooks that I write specifically for this, and that type of thing. So that's what we're looking at doing and using part of to the end of today's session for I've already got an idea. Like I've got the framework set up of specifically what I want to include in this course, but it's really only going to work well if I get some feedback from you all. So those of you that have shown up this time, you get to be a big part of that. You get to be the part that we utilize for building out the courseware. So today, what I want to do is do quite a bit more teaching. Instead of just going through and showing you techniques and commands, I want to kind of do a little bit more teaching and show some specific fundamental things. Like, for example, when you go into a Security Plus boot camp or even a Network Plus or A Plus boot camp, there are so many things that the course assumes you know already, right? And a big part of that is the networking stuff. And part of what I want to spend today doing is going through and just going over some fundamentals of how data gets from one place to the other. This is regardless of whether it's cloud, whether it's on premise, whether it's just from one machine to the other. I want to kind of get into those fundamentals of, look, when you send data from one place to the other, this is what actually happens. When you send that email or when download a file from a web server, here's what actually happens. And again, I think a lot of what we see in the industry is so much of the courses out there, even the quote entry level ones, assume that people know these things. And what I found is people just don't know these things. Even people that I've run across that are seasoned professionals don't understand the basics of how actual data gets from one place to the other. So I figured I would take some time today and just go into a very detailed, involved breakdown of a few different protocols that we use to communicate, and even just understand what protocols are. When people say protocol, what does that actually mean in terms of cybersecurity and IT? I think even that term can kind of throw people off sometimes. So how does that sound, everybody? And this is going to be very demo heavy. Like we'll be looking at packets. I'll show you packets. We'll discuss what's going on with the packets and even knowing what a packet is. Again, I kind of gave the example in the first session that you go into a course that's beginner and they start off talking about packets. Well, if you don't really have a visual construct of what a packet is, you're already lost. All right. So let me just make sure you guys are hearing me and seeing me okay. Let me get some feedback. So does that sound good to everybody? I got a sounds perfect from Xavier, so I know Xavier's hearing me loud and clear. All right, got a response from Christiane. Sounds good. And this is kind of like my audio video check as well, just to make sure you can all hear me. So these responses let me know that. So let me go ahead and get ready to share my screen here. Give Chrome permission to do that. And we're going to dive right into it. And don't hesitate to throw questions in chat, as I go through these, because I want you to stop me and if you have a question and just kind of let me know, like, hey, like, what do you mean by that? I don't really understand what you're saying. Because again, a lot of this is going to be data that I use to build out this course and similar courses for you all. All right, so let's do screen recording. All right, let's try that now. And this is definitely a Chrome issue. Right. All right, just give me a second here. Let me get out of Chrome and jump back in. So I'll be right back. All right, looks like we are back. All right, and I think you all should be able to see my screen now. All right, so let me know if you see a Windows Server desktop. And if just any of you, one of you can just say yeah or something in chat. That'll let me know you're seeing the right screen and we can move on. All right, excellent. So let's take and look at a very basic function. Something as simple as getting a file from one place to the other, because the whole concept of packets and all that, I think a lot of beginners are confused by that. And when we start conversations off with the term packets and monitoring these packets or capturing these packets without really understanding what a packet is, it makes it very, very confusing. So let's do a little, you guys get to see what I'm really, really famous for here, which is my amazing artwork, specifically in Microsoft Paint. Microsoft has officially deemed me the king of paint. So what you need to think about, and this will fill in some gaps so that again, when you do get into a Security Plus or Network Plus or one of those entry level type classes that's supposed to be entry level, you'll understand what these terms mean. If you have two computers, let's just say computer one, and then over here we have computer two. If we're going to send information, let's just say a file. Okay, so let's say on this computer, there is a file. Let's say that file is 1 megabyte in size. Okay. If computer two were to download this file, or this file were to get sent to computer two, what a lot of people have in their minds is that basically what's going to happen is this file is just going to go over like that in one big swoop. And then suddenly that file that only existed over here now exists over here. So in a lot of people's minds, you imagine it the same way you would if Xavier was to actually hand me a file right now. If he were to take a physical file or a physical piece of paper or a physical disk and hand that to me. So what's happening there is when Xavier hands me that disk, or let's say he hands me this this 64 gig SD card here. Let's say he hands me this. When he hands it to me, he is transferring that to me in one motion and it's coming to me intact, exactly as it is here. But when you send a file from one computer to another over a network or over the internet, it does not happen that way, even though to your brain and to the way that we see it, it does happen that way. What actually happened is this file is instantaneously, as you get ready to send it across, it's broken down into thousands of little pieces. It's broken into many, many little pieces. And for the sake of scale, let's do this. So it's broken into many little pieces like that. And instead of the file going over in one big piece, what actually happens is it goes over one piece at a time. Like this piece might go first, then this piece might go second. And that continues until every piece of that file makes it over. Then once all those pieces make it over, now you have on this side those thousands of little pieces of that file. And what has to happen next is now this machine, computer 2, has to reconstruct these file or these pieces in a certain order and put them together, just like you put a puzzle together. This computer has to put that puzzle together to make it equal the same file that was over here when computer 1 sent it. Okay, just the process of getting a file from one computer to the other, that process there has to happen. And when that happens, there are different layers that this file or this data or these packets go through, because at each layer there's information added that will aid in two things. Number one, getting the file or the pieces from side A to side B. And number two, making it so that once the pieces make it to the other side, the receiving machine or computer 2 is able to actually put that file back together in an order that's going to make it be exactly as it was when it was sent. So when you hear the OSI model and the layers and all that, those layers that we're talking about are really just stages and steps that the pieces of this file are going to go through in order to A, make sure it gets to the right place, and B, make sure that when it gets there, the other side knows how to construct it in a way that it is exactly what it was when it was sent. All right. These little pieces that I'm talking about here for the discussion of this class, these pieces that we're talking about, those are what's known as packets. All right. Is everybody with me so far? All right, great. So what does this look like in a real situation though? So what we're going to do is I'm going to go ahead and do this. I'm going to transfer a file from one computer to the other, and then I'm going to show it to you in a packet capture to show you that even though the file is of a certain size, it doesn't go like in one big swoop. It's broken down into pieces and it's sent across back and forth that way. And that's what we're going to examine here. So in order for you to see that, I'm going to introduce you to a tool. Some of you already know about it. It's called Wireshark. And I'm going to have Wireshark capture here. All right. And then Wireshark is now capturing all traffic to and from this machine. And what we're going to do is there's an FTP server on here. And I'm going to use this server for file transfer. Right? So on this machine, we have a file. Let's just find a file that's a decent size. All right, let's see how big this one is. All right, that file's 3 meg, right? That's small, that's nothing. So again, in your mind, you're thinking, well, it's a really small file. So maybe it could happen where you could just send that file in one packet. It's not gonna happen. So we're gonna transfer this file, this rhino.log, from this machine to the Linux machine. And then we're going to look at what that looked like in Wireshark. All right, so let's put it in the directory that the FTP server is pointing to. So rhino.log is there. So now what I'm going to do is go to the Linux machine. Now this machine has an IP address of 172.16.78.199. And if you remember from last week, what we talked about is an IP address is like a phone number. So for one computer to get to another, it has to know its phone number. So we're going to go to the other Linux computer, have it come to this phone number or this IP address to pull down that Rhino file that we put on an FTP server. All right, so let's go to our Linux. All right, so this is a common test. First thing I'm going to do is ping the 199 machine to make sure I can get a reply back. So when you see people doing pings, it really is the same as when you think about a submarine. I'm just sending out instead of sound, I'm sending out a packet that basically says, hey, if you get this packet, respond back to me with a reply. And these replies right here is just the other machine reaching back saying, yes, I can hear you loud and clear. Kind of like what we did when we started the session, when I asked you all to let me know if you're able to hear and see me. This is kind of similar because since we don't have an interactive connection to this machine right now, we can't in real time check it. So we have to send it something and wait for it to reply back. Just like when we're doing YouTube live here, since it's not interactive, I can't look in real time and talk to you in real time to find out if you're hearing me or not. So I have to send you a message and say, hey, can you hear me? And then I have to look at chat to wait for you to reply. So this is similar to what we're actually doing here. All right, so let's see. So within this process, there's a code that tells computer 2 which exact order it's supposed to go to regain that original file order. Yes, and that code is actually something that's put on each packet called a sequence number. So those many pieces of packets here, let's go back to that screen for a second, because that was a good question. So these little pieces that it's broken down into, each one of those pieces has something added to it, right, called a sequence number, and each number is unique. So when all of those pieces make it to the other side, the way that this computer is able to construct it in the right order is by looking at those sequence numbers. Okay, does that make sense, Xavier? Because every packet will have a unique sequence number. So let's just make these sequence numbers here. You know, this would be 1. This one right here might be 2. This one up here may be 3. You know, up to millions, right? So each packet has a unique sequence number. So when it gets to the other side, because here's the other thing. Here's the other thing about that, Xavier, and I'm glad you brought that question up. It's not guaranteed that these packets are going to make it to this side over here in the order that they were sent. As a matter of fact, it's highly unlikely. It's highly unlikely that the packets will make it over here in the order that they were sent. And that's for a lot of different reasons. Collisions on the network could be a reason, and even routing protocols. So the protocols that tell routers and things how to get these packets from one place to the other, they use very finite math to decide which route a specific packet should go to make it more efficient. So it's possible that even though you sent packet 1 first, packet 3 could make it to the other side before packet 1 does. And that's stuff that happens in the routing protocols. And we'll get into that much later in these sessions. But that's something that happens with the routing protocols, because remember, the purpose of a router is to, in the most efficient way possible, get each one of those pieces to the other side. And sometimes the route that packet 1 took is much less efficient than the one route the packet 3 takes, and that means packet 3 could get there first, right? So that's what happens on that side. Thanks for that question, Xavier. That was a good question. So now what I'm going to do is, while we have the packet capture running, I'm going to go ahead and FTP to that server. I'm going to log into it. And then I'm going to bring down that Rhino file. And it says it successfully transferred it. Okay. Now, what did that transfer actually look like? Well, let's get into some fundamentals of the protocol to see that. And I can see Scott there kind of mentioned the three-way handshake. So let's talk about that just a little bit as we examine this. Yeah, that's a good analogy, Xavier. That works. All right. So first off, let's stop the capture and let's understand a few things. Okay, and let's put these beside each other so we can just jump between them. So let's understand a few things. This Windows machine is 199. That's its IP address. And this machine over here, its IP address is 194. So what we're interested in is traffic between 199 and 194. That's 172. There we go. 172.16.78.194 and 172.16.78.199. Those are the two phone numbers or two IP addresses that those two machines are communicating on. That's their phone numbers. So we're only interested in seeing traffic between those two. Now, as you learn to use Wireshark and things like that, you should become effective in the beginning at just learning how to create what we call filters to only see traffic that interests you. Now, right now, again, we're only interested in 199, which is this machine, and 194, which is a Linux machine. So all this other traffic, for us to do our inspection here, we need to try to eliminate everything that doesn't meet that criteria. So here's a basic thing. How do you do a filter? Well, in Wireshark, here's an easy way. I'm going to say ip.addr, so that's short for IP address, equals 172.16.78.199. And then I'm going to say and ip.addr 172.16.78.194. So I'm saying only show me traffic that is related to both these IP addresses. Now look at the number, I'll show you this, look at the number of packets that are involved here. Now, if you look at the number of packets, there's 368 total packets, and there's 368 displayed. All right. Now, we don't need to see 368 packets. We want to see the ones that are related to what we're looking at here. And to apply this rule, watch what happens. When I apply this filter, notice the number of packets that's displayed now drops from 368 to 129. So what I did is I just shortened or cut down the number of packets I'm looking at down to a third. So I'm only looking at 1/3 of the packets we were looking at in the beginning. And when you're trying to do analyzing and trying to learn how these things work, it's important to be able to do this type of isolation right out the gate. Now, look at, normally Wireshark filters and stuff like that, this is something that we teach in the more advanced levels of incident response or network forensics or something like that. But again, this is an example of where my approach is different, because even though this is considered something that you do at a more advanced level, as a beginner, you need to start learning how to do this now. Because when you fire up something like this, you're going to be inundated with the amount of packets. So it's extremely important, even as a beginner, to understand how to just look at the traffic that's related to what you're trying to understand right now. In other words, it makes it a better environment for you to teach yourself in if you can isolate and focus on just the traffic that you care about. Okay. So since we said just between those two, you can see the first thing. Remember, I did those pings. I told you that a ping is I'm sending out a message and saying, hey, I'm here. I need to know if you hear me. And then I'm waiting for it to come back. Well, what you see first is 194 sending a ping request. That's called an echo request. And then you can see coming right back is an echo reply. So that's the machine responding back to me, 199 responding back saying, hey, I hear you. Look at the direction from 192, which is the source, to the destination 199. But the packet right after that is from 199 going to 194. So this is my request going out, and then this is the machine responding back to me with the reply. And you can see that happen several times until I actually stopped it on the Linux side. All right. So what happened next? Well, Scott mentioned Tcp Handshake. All right. So what is the Tcp Three-Way Handshake? This is a fundamental of communicating over network that you have to understand. This is the most important concept to understand as you learn about TCP. Now, when you get into Security Plus and those types of courses, they're going to throw things at you like the Osi model. And there's different layers. Well, what we're talking about here, TCP, happens at what we call layer 4, or the transport layer. And to be clear, TCP actually stands for this right here. It stands for Transport Communication Protocol. All right. Now, let me explain to you what that actually means. When we say Transport Communication Protocol, transmission. Got something else on the brain here. Transmission Control Protocol is what it stands for. The word transmission should kind of let you know that it's talking about the transport layer, right? And when we say TCP, that's what we always mean. So what's happening is when you do a TCP communication, or when you try to connect to a device over TCP, the first thing that happens is a three-way handshake. So you're going to first send a SYN to that machine saying, hey, I want to communicate with you. Is that okay? Here's my communication parameters. Here's my maximum segmentation size. Here's my maximum window size. All of these different things. Now, it's okay if you don't know what those things are, but just know in that first packet, the computer that's trying to connect is going to say, here's all these parameters that I use to communicate. Can you meet these parameters? And by the way, I want to communicate with you and connect you on port 21 because this is an FTP session. Well, again, look at the direction here. That's the SYN. And then the machine that received that SYN responds back with that original SYN plus an ACK, an acknowledgement. So it's saying, hey, I got your SYN request or your synchronization request, and I'm acknowledging the parameters that you are talking about. Yes, I can meet those parameters. Here's my parameters. Okay. Then the original machine sent back an acknowledgement because it's now saying, okay, I've sent you a request to ask you to acknowledge these parameters that I want to set up to communicate. You've acknowledged that. Now I'm going to acknowledge that you've acknowledged what I'm saying so that we can actually start communicating. And then after that three-way handshake, now an actual communication session starts. Okay. And then you can see what happened after that is we got our banner. This is me logging in. This is where the server said, give me a username, and I gave it that. And then the server said, to log into this account, you have to put in a password. Give me your password, and I gave it that. There's the password. Now, the fact that you can see this clearly in Wireshark means one thing. It means that this login or authentication is done in a form that we call clear text. In other words, it's not encrypted. And the fact that you can see these credentials clearly on the screen here is why you will always hear, as you progress in this industry, you should never use clear text protocols like FTP unless you're okay with the world seeing what that information is. Now, I'm only using it because I want to show you these things. I want you to see these things. Again, when you get into a Security Plus or something and they say you should never use clear text protocols, this is what they mean. This is a visual of what it's talking about, because all of this login, all of your passwords that you're logging in with are really, viewable by whoever can see that traffic. And you don't want that, right? Now, what happened after the login? We logged in, and then we said we wanted to actually transfer a file down. We want to pull down rhino.log. All right, now watch closely what happens here. The minute we said we want to do that transfer, there's another three-way handshake that happens. There's a SYN, there's a SYN-ACK, and there's an ACK. But that three-way handshake is happening to port 20 now. Everybody see that? Because here's what you need to understand. When we did this initial connection, right? When we did our three-way handshake to connect, let's just draw this out. So we did SYN. We got back a SYN-ACK. I might have over-exaggerated my Microsoft Paint skills. And then, we sent back an ACK. But see, here's the thing. All of this happened, this whole process that we're talking about here, this all happened in reference to port 21 on this machine. Transmission Control Protocol port 21. And a random high port on this machine. Let's actually go and look and see what that port is. 37700, right? That's the port that it picked. So that connection happened that way. But look at what's going on though. What's happening now is this machine has decided that, like, look, in order for us to do data transfer, to transfer a file down, we need to open up now a separate port from the one that we're sending these commands over. So now we have another three-way handshake, and here's what's interesting about that one. This other three-way handshake is doing this. It's going this way. You got a SYN, SYN-ACK, and an ACK that looks different, because look at where it started. And that, folks, is the port 20, but it's the port 20 on this side. And the port on this side is going to be a random high port. And in that case, that port is 40559. So just to be clear, the first session started in this direction, where the client requested to connect to a port on the FTP server. But the second communication went in this direction, where the FTP server actually requested to connect to the client. And it's on a different port. So when you go into these intro classes and they say things like FTP uses port 20 and 21, well, there's a reason. It uses port 21 by default to allow you to connect initially and to tell the server what you want it to do. But then when you tell that FTP server to give me a file, it's actually making you allow it to connect to you on port 20. And we can clearly see that in the traffic here, because look at this second three-way handshake. There's a SYN going from 199 to 194. Remember, 199 is this Windows FTP server. 194 is the Linux. So now it's clear that this Linux machine, even though it doesn't have a rule in the firewall that says allow traffic on port 20, it's temporarily allowing traffic to come and connect to port 20 from this Windows machine. And there's that SYN ACK right there to port 20. And then the actual file transfer. All of these that say FTP data, that's the file transfer. This is where the actual rhino.log file is coming down. Remember I said that it's broken down into many pieces called packets? These are those packets. These are those pieces of the rhino.log file that's being transferred down. And look at how many pieces it takes to get that file transferred. And finally, it gets transferred down, and then we're done. And then after that, there's a process to tear down that three-way handshake, because look at, first we ended the port 20 connection. So this fin ACK here, this is how you normally close a TCP connection. So we're saying, hey, 199 is saying, all right, I'm done transferring, so I don't want to talk to you on this port anymore. And then what's happening down here is 194 is saying, okay, I'm acknowledging that you don't want to talk to me on port 20 anymore, so let's get the heck off this port. And then there's an acknowledgement of that, and that session is over. So there's no more port 20 traffic. But now, if you remember, in the beginning, we opened a port 21 connection. So we still have to deal with that connection. So we got to break it down. So what happens here, the minute that quit command goes across, now you see a fin ACK, which means I don't want to talk to you on this port anymore for port 21. And then you see an acknowledgement of that, where the other side, because basically what's happening here is 199 is saying, since you said quit, because the quit command came from the Linux side. Well, since you said quit, then that means I don't want to talk to you anymore on this port. And then 194 is saying back, guess what, buddy? If you don't want to talk to me on this port, fin ACK right back at you, I don't want to talk to you either. And then they both acknowledge that, and the session's over. So every time you connect to a web server to download a file, an FTP server, or anything like that, this process happens every single time. If I were to go and download a file, from my website, the same thing would happen. Like, I could do that. I could actually fire up another Wireshark session here and go and download a file off my website, and we would see the same process happen. There's always going to be a three-way handshake to connect, and then you're going to see the data be transferred down, but it's going to happen in pieces. Right? Everybody tracking? Does it all make sense? And I'll just wait for a response here. All right. So let's go ahead and look at an example of the same thing when we go out to a website. So I'm just going to go to a website that I've got some stuff hosted on. And we're going to actually start a Wireshark capture. So I'm going to save this capture so that we can come back and revisit it. And I'll make this available for you all to download so you can study it yourself, because I'm assuming some of you are going to go back and watch this recording, and it'll be helpful for you if you can take this packet capture that I've got, open it in Wireshark yourself, and see what I'm showing you here. And it doesn't matter where you run Wireshark. Linux, Windows, you should be able to open this file in it and see it. And we're just going to make it a regular PCAP, and we'll just call it networking 1. And I'll put this up for you all to download it. All right, so let's start a new capture. Let's clear our filter. We're going to capture again. And this time I'm just going to download a file from one of my websites here. We're just going to get this file. So we downloaded that file successfully, right? It's right there. All right, let's see what that looked like. So I'm going to stop the capture. And look, here's some interesting things that you might try. All right. How would you search for that file name, that and peak file in this traffic? Well, you could do this. You could say TCP contains and peak. And lo and behold, look at, that's where we actually did a get to bring it down. So if you ever want to search through TCP traffic, the string to do that is very human understandable. It's just TCP contains and then whatever that string is. Okay, that's what that is. Again, this is something we usually teach in incident response, but as a beginner, it's important for you to know these basics. How do I open, like if I'm looking at a packet capture, how do I search for certain strings in that traffic? How do I filter based on IP address? That's, that's, if you can do those two things, that puts you really, really a leg ahead, right? So that shows us where we actually did a get to bring that file down. But what I want to show you is the same process happened. Look at the IP. We still got 199, which is this Windows machine that we're on now. But now the other machine that's question is 206, 188, 192, 204. So let's do a filter for those two. And then the other one is that web server, and this is a public IP address. It's going to be 206, 188, 192, 204. So let's just do a filter for traffic between those. And now you can see all that web traffic to my web server where we pull down this peak.pcat file that we did in the browser over here, right? We did that download. But look at, guess how it started? It started the same way the FTP session started. It started with a three-way handshake. There's our two sends where it's being, kind of being persistent there. Hey, sends are like a knock, right? So it's saying knock, knock, and then it didn't get a response back quick enough. So it did a knock again. And then the web server responded back with a send ACK. And then we responded back to the web server with an ACK. So even though this is HTTP, not FTP, it doesn't matter. That three-way handshake still starts the same way. Doesn't matter what other protocol is going to run on top of it. If you're connecting to something over TCP, connect means that three-way handshake completes. So we connected this time to port 443 because it's an SSL session. And then after we connected, we did an SSL negotiation. This is basically, we'll get into that much, much later, but whenever you SSL to a server, right, you have to negotiate with a certificate because you're going to share some secrets with each other and that type of thing. And that's how you get a secure session going. We don't need to go into detail with that, but you can see that this is basically that SSL negotiation happening. But now look at this. Same thing that happened with FTP. Now that we have done all the negotiation on port 443, we got redirected to port 80 because we're doing, yet again, send ACK to port 80 now. And now that we're connected to port 80, this is where the actual request comes to bring down that and peak PCAP file, that zip file. But unsurprisingly, just like with FTP, that thing comes down in pieces. That is that file being pulled down right there, comes down in pieces. And then once it's gotten it all down, guess what happens after that? FINAC, I don't want to talk to you anymore. Okay, I'm acknowledging that. I don't want to talk to you either. And then the session's over. Same process. Now, one thing to note here is this. Because of the sequence number that Xavier and I was talking about earlier, let's go back and look at the packet capture. Let's save this one too. We'll call this web download. Again, so it's just making it easier for you all to know what you're dealing with when you're playing with these later. So let's reopen the one that we did just a minute ago with FTP because I want to show you something. If I open that again and I go back and do the same filter that we did when we looked at it initially, guess what? You can actually take just one packet out of this session. You can right click it and you can say follow TCP stream. And what that does, Xavier, based on the question you asked, it takes each packet based on the sequence number and shows you the entire session as the packets are numbered, right? So if I say follow TCP stream, I can actually see that entire session like this. I could see it as it went. Now, keep in mind, we don't see the actual downloading of the file because remember, that happened over port 20. This session that we're looking at was port 21. We're just seeing the control traffic. But if I went and found one of the packets of where the data was being transferred, you know, where the actual download of that Rhino file is happening right here on port 20, I can grab one of those packets because that's port 20 now. All right, see it right there. And if I right click that packet and say follow TCP stream, that is the actual downloading of the rhino.log file. And since it's a PCAP file, actually, it's going to show up in binary. And that's what it looks like. That's the binary that makes up that file. Now, if it were text, it'd look different. You'd be able to read it in clear text there. And that all happened over port 20. Now, another little important thing that I want to show you about this is, you know, you can turn on and off what we call transport layer or layer 4 resolution, where instead of saying, you know, FTP data, you want to say port 20, right? Like we see here. You can turn that stuff on and off. But I prefer you leave it off because it makes you learn the port numbers. If it just said FTP or HTTP, you would not see the port numbers. And what I mean by that is I could go over here under preferences and I could go to name resolution, and where it says resolve transport names, I could apply that. And then now, instead of seeing, you know, FTP or seeing the actual port number for FTP, you would just see FTP, right? Like look at the very first part of it. Instead of us seeing the actual ports, that first three-way handshake, instead of us seeing that it went from a high port to port 21, we just see it go from a high port to FTP. But if you're trying to get these port numbers in your head, that doesn't help you, right? So that's just a display setting. See it again, the three-way handshake, now it shows 37,700 to FTP and then back and then back. But if we turn off that resolution, it goes back to just showing us the raw port numbers, which is what you want as a beginner. You want to know what these port numbers are. Does that make sense, everybody? All right. So it's been a little over an hour. So what we're going to do is we're going to take like a 10-minute break. So I'm going to give you guys 10 minutes to get water, coffee, bathroom break, whatever you need to do. We'll come back and we're going to keep chugging right along into this. But before I do that, I just want to make sure everybody's tracking and following along okay. And you can respond in chat when you get a chance. All right, let's get ready to get back into it here. All right. So what I want to do is spend a little bit of time, next little bit of this time here to show you we're going down the road of networking here, and we've looked at some very basic stuff. But what I also want to show you is how this very basic concept here extends even into very advanced cybersecurity stuff. So for example, sometimes when we're doing incident response and we're trying to find things on the network, or we're doing pen testing and we're trying to find things to exploit, or we're just doing threat hunting or an investigation and we're trying to find things. Everything that we just covered will come into play in either one of those scenarios. For example, if I wanted to, and you can do this even on your own home network, if I wanted to find all the devices that are connected to my network right now, there are some good tools that are out there in the open source community for you to be able to do that. One such tool is a tool called Nmap. And I'm going to show you two examples of this and how it kind of works out the same way. Now, what I started off doing, looking at this first packet capture here, the very first thing we did was we did a ping, right? If we look at the traffic between these two, we did a ping just to see if the device was there, right? We did these pings and we got replies. Everybody good with that, right? Well, what if we just wanted to do that to every possible IP address in our IP range? And what I mean by IP range is this, and this is another term that you'll hear in the industry that may throw you off if you don't know what they're talking about. If I say in my IP range, what most of us mean when we say that is IP addresses that fall within the range of the network that I'm actually on. So if my IP address is this, right, this machine has this 199 IP address. All right. The other machine has a 194 address. That means that they're both on this network. And what that network means is, I wrote it in shorthand, what it really means is this. Now, we talked about this being like a phone number, right? This part is a phone number. Well, when you write it in this notation, every phone number has an area code, right? Because you can have two people with 387-4488 as their phone number, but each one in a different area code. So this part on the left would be your phone number, and this, what we call a subnet mask here, is like your area code. Okay, so since each one of these octets here represents 8 bits of space, if we're saying we're using the first 3 octets for the mask or the area code, then 3 times 8 is 24. So the shorthand way to write that is like this. Okay, we don't need to get into the math of it. You can do that when you take CCNA and get into subnetting and that type of thing. You don't need to go that deep into it for you to understand what this is when you see it. So what I'm saying then is, if one machine has this IP and one has this, then are there any other devices in that network range? And when I say range, it means from here, that would be the bottom end, all the way up to here. So that's 250, for IP addresses that are possible to fall within this same range. How do we check to see what else is on this range if there are any other devices connected? Because see, the thing that's missing here, what people don't understand, is when you connect to your network at home, you have something called a router. And this is usually wireless. Like most of you have a wireless router. You have a wireless router. Let's put some antennas on that thing. You have a wireless router, and built into that wireless router is a server called a Dhcp server. This is just an application. And what that thing does is it has a pool of IP addresses, in this case, that ranges from here all the way to here. And as devices connect to this router, it leases each device one of these IP addresses. So it's got this whole pool of addresses like this. Let's say device 1 connects, it might give it the .1 address. Or, let's just say the router has the 1 address itself. So its pool might start at, let's just say 10. So as your devices that you like, your Apple TV and your Echo and your smart TV and every kid's computer and your cell phone and your iPad, as your devices connect, they all will get unique IP addresses for this network, and they'll be leased or handed out by this server that's built into your wireless router. All right? Every device that connects will get one of these. So if you've got a bunch of devices connecting and disconnecting, at any point in time, how would you find out what's currently connected and what IPs they have? And this is where some of those other tools can come in, but you do need that basic understanding of the networking that we started off with to do that. So in other words, how do I ping, instead of pinging one IP address to get it to respond back, how do I go through and ping all of them? We could do ping space 172.16.78.1, right? We could do this. We could start like this. We could say ping. And say, oh, we got 4 replies back from that. So that means that one's up. And then we could say, all right, now let's do .2. Ah, we got 4 replies back from that. So we know that something's there. Now let's do .3. You could do that. And we could say, all right, we didn't get a reply back, so there's nothing at .3. You could do this, but how long would that take? And in this day and age, doesn't it just seem ridiculous that you would have to do that? And the reason it seems ridiculous is because it is. There are many, many tools that will allow you to do this, and we're going to focus on just one, because this tool, you'll be able to use it for pen testing, for incident response, for threat hunting, for just basically checking the sanity of your network to see what's there. You'll be able to use it over and over and over again for many different applications. All right. Now, the way that I do that, we're going to go back to the Linux side here. I'm just going to tell this tool Nmap, look, here's my network. And I want you to tell me what devices are responding across all 254 of these IP addresses. And the way that I do that is I'll do what we call a ping or discovery scan, which is done with a little s and a big N with the dash there. That's it. This is the only Nmap command you need to know to find stuff on your network or on any network. Now I go ahead and run this, and it comes back and tells me that, look, out of the 256 possibles, because it actually started at 0 and went to 255, out of the 256 possibles, there's 5 devices that are connected. They have the IP addresses of .1, .2, .199, .254, and .194. That's what it's telling me there. Now, if I stood up another device, let's just stand up another device on this network and see if the number changes from 5, right? To prove to you that I'm not just making up stuff here. So let's stand this old person up here, this grandpa. You can see it's got an IP of 139. All right. So let's see if Nmap finds it. We run that exact same scan again. Notice now it says there are 6 devices on the network. And you can see the 139 device show up there. So this is a quick way. And the reason I'm showing you this is because a year from now, by the time you all are to the point that you're ready to start trying to learn pen testing or incident response or something like that, this will already be baked into your ethos. You'll already have tremendous hands-on experience with this tool to where you won't even think twice about popping it up and using it for some of the stuff that you'll learn to use it for later. Because if you start using it today to discover things on your own home network and stuff like that, you're building that muscle memory to where you're learning about this particular tool. And let me tell you, you will not, if you do any technical cybersecurity job, you're probably going to run into this tool at some point. All right. Now, I've got Nmap running on my actual host machine, my actual MacBook. And I want to show you something, or excuse me, my Mac Pro here. So if I go and open a terminal on my Mac, I can look at, first of all, I can check my IP, right, and see what my actual host IP is. And on the Mac, you know, it shows up, the interface show up as different names. But for mine, the interface is EN1. That's my wireless card. The IP address is 192.168.0.29. So that means that 192.168.0.0/24 is my home network. So if I wanted to find out what else is on it, I could do this. And see what shows up. I'm not sure why it aborted there. Sometimes there is a permissions issue. Yeah, I'll come back to that. I'll show you that when we do our Zoom session in the end. But I know what's going on there. I need to change something. But you know, you get the point. This is how you check on your own home network or anywhere that you have permission to see what else is there. Now, again, I want to caveat and say, don't do any of the stuff that you're learning in these sessions at work if you don't have written permission from work to do these exact things. If you want to try this command at work, I suggest you show whoever's going to give you permission this exact video or this clip of the video and say, I want to do this on my practice network at work or wherever it is. And you need written permission. If you don't have written permission to do this exact command, don't do it. Do it on your home network or something that you have control of. Right? And that's just to keep everybody out of trouble, because on some networks, you can actually get in trouble for doing something as benign as this. Like, you can actually get fired for that if you don't have permission. So just be careful with all these things that I'm showing you. If you're going to practice it at work, make sure you have permission to do that. Now, the one other thing that I want to show you about this tool, we were talking about ports. We were talking about the fact that we connected to this machine right here over FTP. And the reason that was happening is because, remember, we connected to port 21. Right? We go back and look at the traffic. What you'll see is all those connections, the connection to FTP happened on port 21. Well, what if this person changed their FTP server and said, you know what, I'm not going to follow the normal rules of FTP? How would you find out what port that FTP server is running on? Or if you just wanted to check to see if port 21 is even open, because the port has to be open for you to be able to do this. If you try to do a three-way handshake to a port that's not open, you won't be able to complete that handshake. Okay? Everything we've talked about up to this point about connecting to ports and the three-way handshake, it's only true if that port that you're connecting to is in a state of open. Let me illustrate that. Let's do another capture. And we'll filter traffic between these two. And I'm going to start a Telnet server. This is another term you'll hear about. Now, if I try to connect to port 23, on this machine, I'll get a connection. You know why? Because Telnet uses port 23. I'm logged in. But what I want you to notice is, just like all the other stuff that we looked at, how does it start? It all starts with SYN, SYN-ACK, ACK. It always starts with that three-way handshake. And generally speaking, it's always going to end with that FIN-ACK. Hey, I don't want to talk to you anymore. Okay, I'm acknowledging that. And if you don't want to talk to me, I don't want to talk to you either. That's the FIN-ACK back, and then an ACK to close out the session. It generally will end this way, and it will generally start this way. Always. But that's only the case because that port is open. If I try to Telnet to port 22, which is not open, we're going to see something different. So let's do another capture. And now we're going to try to Telnet to port 22. This is where you get the unable to connect in this case. But what does the three-way handshake process look like when the port is closed? Let's go see. We tried to do the same thing, right? The Linux machine tried to do a three-way handshake. It started with the SYN, just like it always does. But since that port is closed, instead of the receiving machine responding with a SYN-ACK to say, hey, it's okay to connect, it responded with a reset and said, look, dude, I don't know what you're talking about. Like, I don't have that port open, so I can't allow you to connect because I don't have that port open. You're trying to come into a door that doesn't exist right now, or it's locked and closed. Right? So that means then we have a standard that we can go off of. If I want to know if a port is open, let's say 21, I can Telnet to that IP and the port number, in this case 21, and if that port is open, I'll get a connection that would look like this in the traffic. SYN, SYN-ACK, ACK. That means, that universally means I connect. But if the port is closed, then that means if I tried to connect to that port, let's do port 81, then in the traffic, it'll be a send coming from me and a reset. That's a predictable pattern. Let's go and connect to another open port. Let's try port 80, which is the web server. We got a connection. What does that look like? You can see the same pattern. Send, SYNAC, ACK. So when the port is open, you're always going to see this with the connection attempt if you're allowed to connect. And when the port is closed, you're always going to see send and reset. All right. Now, does that make sense to everyone? If it's open, you'll get the handshake. If it's closed, you'll get a reset. Great. So then let me ask this question. Who can tell me how many TCP ports are there? What's the number? The ports ranges from 0 to what high number? How many possible ports are there? Who can tell me the answer to that? And I'll give you a few minutes to respond. All right, let's see what answers we got so far. Anybody got the answer? Zero to 65,535. So there's 65,535 possible ports. So if it's that many possible ports, how can we look at one machine and check it quickly for all 65,535 ports? How can we do that? Like, how can we check all of those ports on that one machine to see which ones are open and closed? In other words, this manual thing that we just did here, where we sent a send and got back a reset, so we know 81's closed. We sent a send to 80 and got back a send ACK, so we know port 80 is open. How can we do that 65,535 times quickly? Well, it's pretty easy, actually. Using the same tool, we can tell Nmap to check that machine, and that process that we just did manually where we're trying to connect, and if we get back a send ACK, it's open. If we get back a reset, it's closed. We did that manually. We can tell Nmap to do that to this IP by telling it to check ports 1 through 65535. We could do that, or we could just say -p-, which means check all ports. That's a shorter way to do it. And what's going to happen is it's going to check all 65,535 ports. Now, on the traffic side, as you can imagine, that's going to generate quite a bit of traffic because it's 65,535 probes minimum that it's sending out there. So look at how high the packet count got, right? From 368 that we started with. But the beauty of it is, look at what Nmap is able to tell us from doing all that traffic. It's able to tell us that, look at, out of the 65,535 ports, these ones right here are all open. All these ports are open. That's what it's telling us. So we know that we can three-way handshake any of these ports that's listed here. And it tells us like there's 65,501 that are closed. So if we count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. There's 34 ports open. There's 65,501 closed. If you add 34 to 65,501, what you get is 65,535, which is the total number of possible ports. So what we did manually, think about how long it took us to manually do this command, get the response back, and then decipher what it means. Took us like 5 seconds to do that. Nmap did all 65,535 ports in 17 seconds. This is why you need tools, because yes, you can manually do it. And the reason I made us manually do it here is to understand what's happening. But now you can see what it looks like when you use something to automate that. So when you hear people use terms like, well, you have to, that port's not open, or TCP or FTP uses port 21, what they mean is the FTP service is running and it's listening on port 21, or it's opened the door on port 21 and it's waiting for stuff to come in. That's what a service using a port means. And to prove that to you, we can change the port that the FTP server listens on, right? Like I can go to my FTP server and I can tell it, I no longer want you to listen on port 21. I want you to listen on port 93. Now my FTP server is listening on port 93. And if I were to, let's start a new capture here. If I were to now FTP to that server without giving it a port, the FTP client's going to default to port 21. So if I try to just do that, it's going to say refused. Why? Send, reset. Port's closed. There's nothing listening on port 21 anymore, right? So if I were to go though and I were to tell the FTP client, FTP, but by the way, try using port 93. Handshake completes because port 93 is open and that's where the FTP server is now. So now I could actually log in. Now I'm connected to the FTP server on port 93, not 21, but guess what? If I were to try to bring a file down, like we brought down the rhino.log, if I bring down crack.txt, it got it. In this case, it still used port 20 for that. Remember, it only used 93 for the sake of simply generating the the traffic to get your connection going. But it still used that port 20 to do the actual data transfer. So that's how the protocols work, and that's how the ports work. So again, when you go into these classes and you hear terms like, oh, well, FTP uses port 21, when they say that, or when the textbooks say that, what it means is this. It means that typically, if someone is running an FTP server, they're going to configure that FTP server to listen on port 21 for connections. That's what that means. That doesn't mean that every FTP server in the world is listening on port 21. Most of them are, because when you stand up an FTP server or you configure it, by default, generally the FTP server is going to listen on port 21. So Xavier says, how did we know the possible ports were 0 to 65,535? Because that is a standard rule. So all of these protocols, TCP, FTP, UDP, ICMP, they're all described and designed and architected in some documents that you can go read called the RFCs, or requests for comments. And the RFCs for TCP and UDP have stated and put the limit that there are 65,535 possible ports that you could use. That's the limit. There's no more, no less. So that's something that's hard coded into the protocol, Xavier. Does that make sense? And to answer your last question there, yeah, that's the number no matter what. And Xavier, I'll just wait for your response there before we move on. All right, excellent. So now that we've covered those basics, and again, I encourage you to go back, watch these videos over and over again to get this baked into your head, because we're going at a rate and at a level that you're able to digest it. And the more you digest it, the more it's going to be baked into your brain, so that when you sit in these conversations or you get into these courses and these terms start flying out, you can follow and you can learn the stuff that you're supposed to be learning, instead of sitting there trying to have to Google and go look up what a port is and what TCP is and all that. These things you'll have kind of baked into your brain, and it'll set you up for success when you do get into these courses. All right, so that is how that works. Now, when it comes to networking and doing that kind of stuff, all these things, Nmap and all that stuff is what allows you to be able to, to kind of do these things. So does everybody still have their skills account? Because I'm going to have you go into skills and do something to reinforce what we just looked at. And if there's anybody that's watching this stream that does not have a skills account, you just have to go and get one. And if you don't know how to do that, you can go back and watch the first stream where we go into how to set up that skills account. But let's go into the skills account, because I'm going to give you guys a little bit of time here, because I want you to do some stuff. So in your skills account, just go to Learn Cyber Ranges. And then once you're in here, go to the penetration testing. And I'm going to have you work through the TCP IP for hackers. It's a good little primer for understanding how TCP IP works. And it's the stuff that we just learned, this kind of adds onto it and reinforces it. So the first one here, you're going to use a tool called Net Discover. Just simply check this range. See if there are any devices that are operating in that range. So this is, again, another tool that you can use on your home network or whatever to see what devices are actually working there. Now, within the context of this course, I think one of these Saturdays will take an hour. Maybe the next month when we do this, I think we're going to take an hour for me to just walk everybody through how to set up something to practice with at home. That way, if you can't get on the internet or something like that, you can still practice. So you can see it's checking that entire network range. You can see the numbers going up there. And I don't need you to do this with me. I'm going to give you guys some time to work on this, and then we'll come back and discuss it after everyone's worked through it. So you can see it's almost at the end of that network. When it gets to 255, that'll be the end. All right, so now it says finished, right? So now that it's finished, I'm just gonna follow what the instruction says and Control C to exit. And now you're gonna get to do a little bit of what I just showed you with Nmap, right? So it's gonna have us to run Nmap. And you can pick any one of those hosts that you saw there. I don't know if 26 was available on mine or not. Let's do net discover again to find another one. Let's go with so .2 is available. I'll just scan that one. So what you're supposed to do is pick any IP that showed as up and scan for port 80. And you'll see in my case, it says that it's not open. Let's go through some others here. Now, while we're waiting on this, we talked earlier about ping, right? And how we can use that to discover stuff. So some devices come out of the box secured in a way that ping is disabled. In other words, it's not going to respond to a ping. It'll just sit there and ignore you, which it's trying to keep you from finding it. So when that happens, you can tell tools like Nmap to not do a ping. So if I wanted to say, tell Nmap, like, look, I know this device is up, so I don't want you to ping it. I just want you to scan port 80. You can do -pn, which tells it to ignore or not to do the ping, and it just does the port scan. So notice how when I said do the scan without the PN, it comes back and lies to me and tells me that the host is not up. That's because it's basing this 100% off whether or not that host responded to a ping. But if I say, I don't believe you, I think the host is up, so don't try to ping it, just do the dadgum port scan, it'll come back and say, all right, I changed my mind. Actually, that device is up, right? And that port is filtered. And this is important because I want you all to see just one flag can be the difference in you believing a lie that it's not up, or knowing the truth, which is that it is up, right? So that's an important little concept to get there. So we go ahead and run this. Let's do 280.180.1. It's another device that was up there. And we can see, you know, with the PN, it tells us it's up or not up. Okay, so that's what that little step is based on, is you finding, you know, whether or not port 80 is open on that device or not. Now, again, the steps are net discover, get a list of open devices. So let me let that run. I'm going to answer these questions here in chat. Is there coupon code still available? Yes, it is. That coupon code is I think it's Keatron intro 22 or something like that. Let me check my email. Does anybody in chat still have that coupon code? I want to say it's Keatron intro 22. All right. While we're waiting on that to run, I'll check that email. So Keatron intro 22, yes. So the code, Edward, is this. And that's just intro. I think that'll give you some time. All right. So let's just pick another one of these and just kind of showing you what it looks like when we do the scans. So I'm going to try 147, 133. And as soon as we find one that says open, it takes us on to the next step. So then you're going to run Tshark, which is like Wireshark, but on the command line. So it's just a sniffer. And what's happening here, whoops. Still not used to this keyboard yet. So what's happening here is you're telling Tshark to listen on interface loopback. You're creating a filter for just traffic on TCP port 80, right? So that's what we're telling Tshark to listen for. So that would be the same as if in Wireshark, we had said TCP.port EQ 80. This is the way you do it on the command line at Tshark. All right, so Tshark is listening on port for traffic on port 80. We need to switch tabs here so that we can run other commands in that tab. And now we're going to have Nmap run again. I want to show you all something just so you won't get your brain confused when you see this happen as well. See how the instructions say st-p80 skill set local? Watch this. I'm going to change the order. Notice how even though the order of my command is different, Nmap is able to interpret that. It's not going to make a difference. And I'm able to move on to the next step there. So I'm going to give you all about 30 minutes to work through this exercise on your own. And I'm just going to kind of stand by here. If somebody's got a question, put it in chat, and I'll be happy to jump in and explain it or answer your question. And let me just put up on the screen what you're doing here. So I just put in chat which module. So in the cyber ranges, so you go to learn cyber range, and then you click on, the penetration testing range. And the TCP/IP for hackers is the one. So under cyber ranges, you want to pick penetration testing. And then in the penetration testing range, the lab is TCP/IP for hackers. All right, everybody should be done. And let me know that, because we're gonna go ahead and let us jump on the Zoom so I can talk with you all. So let me get that going. All right, so I'm going to put the Zoom meeting invite in chat. So here's the meeting invite, and let me just give you the passcode. So we're going to take it to Zoom now so we can do this interactively. And I will definitely make the Zoom meeting available to you all as well. I've got the last one from the last week recorded, and I'll just have those uploaded also. And I'll just wait for everybody to join Zoom, everybody that wants to. Let's see why the invite didn't show up there. Let's try to do that again. Let me try to create a short version of it. Yeah, I'm working on getting it in the chat now. I'll just do it from my machine here. All right, let's try this again. Are you able to see it now? All right, I see a couple of people have joined, so I'll just give it a few minutes for the rest of you to jump in. Now, what I'm going to do is these PCAP files that we were working with, I'm going to upload those in the Zoom meeting here so you can download them right from Zoom for those of you that want it. And I'll also put it on Amazon, put it on in an S3 bucket so you can download them from there as well. But is there anybody else that wants to join the Zoom meeting that hasn't yet? I don't want to start that session, or I don't want to start talking on it until everybody that wants to jump in gets there. And if you guys are talking, I'm muted on Zoom because I don't want the feedback to go back and forth between Zoom and this YouTube Live. So I won't be able to hear you for a few minutes. So just go ahead and join and just hang out there. All right, I still looks like one person still trying to get in, so we'll give them just another minute. All right, so one thing I want to do is the PCAPs that I was working with and the stuff that we were going over. I've just put those on AWS. So let me just share it, and I'll make those available. I'll make the link available for you all to download that, so that as you go back and look at these exercises, you can practice this. All right, so I've just put that link in chat on the YouTube meeting there, and I'm going to also put it in the Zoom meeting as well. But can somebody verify that you're able to download the PCAPs? It's just a zip file there. All right, so I think we got just about everybody. I don't have anyone in the waiting room anymore. So I'm going to assume that if you intend to join the Zoom session, you've already joined it. So I'm going to go ahead and end the stream on YouTube, and we're going to go live here with Zoom. So see you guys over on the Zoom meeting.